The Electron for Dummies. Act 1. First of all, where does the word electron come from? From the Greek electron, amber. Around 600 BC, Thales noticed that amber rubbed with the cat's skin attracts light bodies. But the play did not really begin until almost 500 years later. In the 17th century, the showmen used static electricity discharges to surprise spectators. They even made a memorable demonstration in Versailles in front of Louis XIV. A little later, in 1733, the intendant Charles Dufay realized that amber and sulfur electrified by friction had an opposite effect to that of glassy products. He therefore distinguished negative electrification from positive. With his balance, Charles Augustin Coulomb succeeded in establishing the relationship between the force of electrical attraction and the square of the distance. Around 1770, Luigi Galvani showed that the electricity collected in a Leyden bottle caused the legs of a dead frog to contract. The Leyden bottle is a kind of capacitor discovered by Ewald van Kleist in 1745. A natural phenomena, which had been known since antiquity, helped to make progress. The discharges of torpedo fish put Alessandro Volta, in 1799, on the path of the electrical battery. He stacked alternating discs of two different metals separated by acid-soaked felt discs. He thought of reproducing the muscles of the torpedo fish. Napoleon himself was impressed. Immediately afterwards, in 1802, Giandomenico Romagnosi discovered that the current produced by a Volta battery turns a magnetic needle. This experience was considered absurd by the Paris Academy of Sciences. For heaven's sake! Electricity has nothing to do with magnetism. And yet. Act 2. Romagnosi's experiment was taken up in 1820 by Rystad and it's kept his name. André-Marie Ampère then realizes that the rotation of the magnetic needle depends on the direction of the current, which confirmed the existence of positive and negative electricities. The same Ampère noticed around 1830 that electrical wires attract each other if they are crossed by electric currents of the same direction and repel each other otherwise. He deduced that electrical currents produce magnetic fields which explain both the deviation of the magnetic needles and the effects they have on each other. Ampère proposed to explain these phenomena by a current of innumerable electrically charged particles moving in the conductor. The Paris Academy of Sciences rejects this theory, which was considered really stupid. Ampère died forgotten at 61 in 1836. Completely rejected by scientific mainstream. And yet, at the same time, the positivist vision theorized by Auguste Comte was emerging. The positivist approach is based on an axial vision of history. Its chronology ends with an ultimate state, the scientific state. And Comte's positive science is based on mathematics, the culmination of knowledge. Out of mathematics, no salvation. Newton served as an example. Gravitation is a force expressed by its well-known mathematical law. If there are other forces in nature, the only thing that matters is finding their mathematical expression. Off we go. Act 3. Maxwell will mathematize electricity. As soon as a mathematical law makes it possible to find the experimental results, it therefore becomes an indisputable truth. This is the great positivist postulate. Maxwell's equations are therefore certain and admit no doubt, no debate. Maxwell formalized Ampère's discoveries. He did not believe in its particles which would have flowed into the conductors. But he attributed magnetic fields to electrical current in his famous Maxwell-Ampère equation. Questioning this mathematical interpretation of the experiments of Romagnosi and Ampère is blasphemy. Blasphemy against the positivist doctrine, the intangible doctrine of the progressive mainstream. Joseph John Thomson discovered the electron in 1897 with a cathode ray tube. Ampère was therefore right. Thomson thought that the nuclei of atoms are small clouds of positive and negative charges. But in 1811, Ernest Rutherford showed that the positive charge is concentrated in the nucleus of atoms. In 1897, Jean Perrin confirmed the negative charge of the electron. Electrical currents are therefore flows of electrons in conductors. And these electrons move in the opposite direction to that postulated in Maxwell's equations. Bad luck. No one succeeds in measuring the speed of the electrons and the conductors. Calculations based on Maxwell's equations give a few centimeters per second. The Maxwell-Ampere equation is therefore based on a hypothesis, a postulate, without any experimental evidence. It does not matter since, in the Great Progressive Movement, the equations remain consistent with the experimental results. Let go. Act 4. Rutherford hypothesized a planetary atom. The electrons would orbit the nucleus like the planets around the Sun. But this very anthropomorphic model was immediately rejected because the electrons rotating in their orbit should emit electromagnetic radiation. They should therefore lose energy and collapse on the nucleus. The progressives will therefore impose the idea that physical models are of no use in physics. For the progressives, nature has no reason to bow to human reason. Anything is possible and only matters the mathematical formulation of even the most incomprehensible phenomena. A first improvement of the Rutherford atom was presented by Niels Bohr in 1913. The electrons would rotate in stable circular orbits. What does the word stable mean? That the electrons on these orbits would not emit electromagnetic radiation. The tragedy is that Bohr's premise already contains the hidden belief that the motion of electrons is not the cause of magnetic fields. Hide these words that the progressives cannot see. By changing orbit around the nucleus, the electrons emit or absorb energy, a photon, depending on whether they move towards or away from the nucleus. In the meantime, Albert Einstein came, helped by a few goldsmiths of mathematics. He deduced from his theory of relativity that mass is equivalent to energy. Does the photon have a mass? A large majority of scientists think not. But it has energy. What can the word energy applied to a massless body mean? Do not try to understand. The mathematical formulas give results that are consistent with the measurements. It doesn't matter that you don't understand anything. This damn photon will push our dear electron into a great scientific leap forward. Act 5. Louis de Broglie assumed in 1924 that the photons are both a particle and a wave. And he extended his postulate to all the particles and thus to our electron as well. This hypothesis was verified in 1927 by Davison and Germer, who obtained diffraction circles. Subsequently, we got interferences with electrons, then with huge organic molecules which must therefore have an associated wave. Perhaps we too, without knowing it, have an associated wave. Statistics will play a dominant role thereafter. Statistics are an integral part of mathematics despite the widespread belief that they are not exact. In reality, the statistics are mathematically accurate. The problem is not in the statistics, but in the homogeneous batches to which they are applied and in the criterion. The probability relates to a given object, a racehorse for example, in a batch of horses, and a criterion, the rank of arrival in this case. One can be interested in the batches of stops of a bus line. The criterion may be the presence of a bus at a stop during a given time interval. A bus has a certain probability of being present at the stop within a quarter of an hour. This probability is deduced from repeated observations over a long period of course. Conversely, it is absurd to pretend that an isolated being could be subjected to statistics. The probability can only relate to an object of a homogeneous batch. Scientists are well aware of this difficulty. They get rid of it by taking as a lot the geometric points of a space considered at a given time. One cannot deny their homogeneity, the points are all identical in the nothingness. A photon thus has a certain probability of being at a determined point in a batch of points at a given time. But, the photon moved. The batch of points is no longer the same. The photon should therefore have another probability of presence perpendicular to the previous one, if I dare say, in the direction of propagation. However, this is wrong because the photon has an absolute speed and its presence in the next batch at the next instant is absolutely determined. If the photon, like all particles, has two natures, wave and particle, it also has two simultaneous states, probabilistic and deterministic. All this makes no sense. But I warned you, the problem is not to understand, but to find mathematical formulations. The photon was a terrible tragedy that ends in a grave. The electron wants to exist. It doesn't want to enter the huge farce that scientists want him to play. Our scientists in blue jeans are so happy to show off their mathematical hogwash. Do not tell them. Do not discourage the mainstream.